Hello, welcome to Watkins Waggles. In this video we're going to be talking about any questions that involve percentages. Percentages appear throughout all of your science papers, whether it's biology, chemistry or physics, and relies on your basic math skills of being able to work out a percentage, but there are also some specific questions within the chemistry that requires you to do some certain percentage calculations. Now, the first thing that we need to remember is that in science exams in particular, you will always have a small number divided by a bigger number multiplied by 100. Okay, just remember that. Small number, divide it by a bigger number, and then multiply it by 100. That's not necessarily true of maths or other subjects, but it is always true in science. Small number, divide it by the bigger number, times 100. So let's look at some example questions that require us to use percentages. First thing to have a think about is the fact that in the exam papers that we've got, they obviously word them slightly differently, but they follow the same theme. They will always have the word percentage in them. I'm starting off with the May 2013 higher paper, but this question can also appear in the foundation paper, and I found a question that has got the word percentage in it. This one says, calculate the percentage by mass of carbon in sodium hydrogen carbonate. So first of all, it's a calculation, so we know we're going to have to use some numbers, and we've also been asked to calculate the percentage. Now they've said calculate the percentage by mass. All they mean by that is use masses, use atomic masses, formula masses to work out this percentage. So you'll notice there's not a single number in the equation. First thing that tells me is there might be some numbers towards the beginning of the question, there might be a need to use the previous part of the question, or probably I'm going to need to use my periodic table. Right, percentage, small number divided by big number times 100. So I've got to do the mass of carbon within sodium hydrogen carbonate. If I look back a question, it asked me to calculate the relative formula mass of sodium hydrogen carbonate, and it gives me the formula and it gives me the atomic masses. As soon as I see relative formula mass, I think add them. Okay, add the atomic masses together to work out that calculation. Let's do that one first. So relative formula mass, whenever you see that, you're going to add the atomic masses together. Now we've got a formula that involves some brackets. Okay, we've got NaHCO3. First thing I'm going to do, my apologies, there aren't any brackets in it at all. The actual formula itself was within brackets. So what we need to do is to add together the atomic masses. It's given me them in the question. Sodium is 23, hydrogen is 1, carbon is 12, and we've got 3 times 16 for the oxygen. 3 times 16, again, you could do this in your head, but why risk making a silly mistake in an exam? 48, and then all I do is I add those together. So 23 plus 1 plus 12 plus 48. I end up with 84. I'm obviously going to check that twice. You wouldn't want to make a silly mistake in a question that you should get full marks on every time. So 2 marks just for doing that. Remember, relative formula mass, or if you see the symbol MR, it all means the same thing, add them. You're just going to add the atomic masses together. Right, we've done that. So we now have, remember this was sodium hydrogen carbonate. They've asked us to use it here. We need the mass, it's all about the mass. The mass of sodium hydrogen carbonate we've just worked out, that's 84. We also need the mass of carbon. The mass of carbon was just up here in the question, it's 12. Okay, so they've given us all the clues that we need. 12 is a smaller number than 84. 12 divided by 84, this is the percentage by mass of carbon, this number here, in sodium hydroxide, but we need to work it out as a percentage, so we'll multiply it by 100. 12 divided by 84. Press the equal sign afterwards means you're always going to make sure there's no mistakes. Times it by 100, I've got 14.28571. Now if I wrote down the whole answer, I will get full marks. In a science exam, if it doesn't tell you otherwise, that is always the case. But sometimes they expect you to record it to 3 significant figures, in which case our answer would be 14.3, because that 8 after the 2 causes us to round it up. They've already given us the unit, it's only worth 1 mark, we've achieved that percentage. So what other kinds of percentage questions could we get? So looking at a different exam paper. This exam paper is from May 2012. It's a higher paper. Again, I can question spot quite easily because very clearly in this question there's a hell of a lot of information. Aluminium is extracted from aluminium oxide. The formula is Al2O3. The relative formula mass is 102. I've been asked to calculate the percentage of aluminium in aluminium oxide. So yet again, I need the percentage of one element within a compound. I've been given the masses and its percentages. So back to our little reminder, small number divided by big number times 100. It's all about the mass, okay? I know this because all the way through the question it's telling me formula masses, atomic masses. So when I calculate this percentage, I need the mass of aluminium in aluminium oxide. Whatever that comes after the word in, that's the number that's going to go on the bottom of your calculation. So aluminium, here's the formula. It's Al2, okay? So there's 2 aluminiums within this compound. So we've got the mass of aluminium, it's 27, but because there's 2 of them, that little number there, we need to multiply the 27 by 2. So 27 times 2. Again, use your calculator. There's no harm whatsoever in just making sure, again doing it twice, making sure you don't make a silly mistake. Okay, so that's 54. The larger of the numbers, I need the mass of aluminium oxide. Good news is, they've already given me that in the question. The formula mass of aluminium oxide is 102. So I don't even have to worry about that. I've just put one line through that working. Could have just left it there. The examiner can still read it. They've seen what I've done. So small number divided by a big number times 100. Small number divided by the big number times 100. Stick it in my calculator. 54 divided by 102. Press equals times 100. I've got 52.94. Again, I'm expecting that number to be less than 100. Okay, because I can't have more than 100% of a chemical. So again, I can put down the whole number if I want. They've already done the units for me. I don't have to worry about that. But I'll do it to 3 significant figures. So it's 52.9%. That's 2 marks, absolutely sorted. One final example then. You can also be asked about percentage yield. Okay, this word yield, here we go. Calculate the percentage yield. The word yield just means product. Okay, how much have they made of what it was they were looking for? Okay, so the company calculated in this case they would produce 1.2 tons of magnesium, but they only got 0.9 tons in the end. That's their yield. You also have to know reasons why you might not get 100% yield, but that will be covered in a different video. So again, calculating a percentage. All I need to worry about is the fact that I've been asked to calculate a percentage. It's science. So it's a small number divided by a big number times 100. I've got 2 numbers in the question. So I simply take the smaller of the 2 numbers, 0.9. I divide it by the bigger number, 1.2, and I times it by 100. Put it into my calculator, 0.9 divided by 1.2, 0.75 times it by 100, 75%. I check it again just to make sure I've not made a silly mistake. 0.9, that's the right number. 1.2, correct number again. Small number divided by the bigger number, press equals, times 100, job done, and there's 1 mark. So, just to recap, any question in science that involves percentages, we're going to focus on the fact that you need a small number divided by a bigger number times by 100. If the question is about the mass of the elements, you need to maybe look for the previous part of the question in order to work out the formula mass, or look for any clues they've given you. Double check it in your calculator twice, and don't forget that if they haven't given you the percentage symbol, do not leave that number all by itself. Make sure you write the symbol. Better that it's there twice than not at all. Good luck, happy revising. That was your video on questions that involve percentages.